Hi students, welcome to Malaysia. I am alone in my primary host's apartment right now, and let's see, for me it's Monday morning, for you it's Sunday night. It's sunny outside. I've got a couple different fans going to keep me cool in this muggy warm weather, and I've got a very simple and straightforward lesson for you in lesson 87. Bear with me. I hope my pencil and my pen, or my pen and my paper are okay. I'm kind of making do with the backs of pieces of paper and a pen that isn't ideal. So I hope you can see this okay. The topic of this lesson is a single topic, and it is slope formula. So as soon as you hear the word slope, I hope this jumps right into your mind. This is our slope-intercept formula of a line, and we've talked about it probably a billion times. And as you know, x and y are a series of different points that will always make this formula true, this equation true for any particular line. You can plug in lots of different values for x and y, and they will always be true and they will always be graphable. But then we have this thing called a b, and that's a y-intercept. And as you guys well know, that is the place where our line is going to cross the y-intercept. So it's different depending on where the line crosses. But today I want to talk about the letter m. And as you know, the m is the slope of the line, the angle, the tip of the line. It can be a line that goes uphill, it can be a line that goes downhill, and we can quantify this line to describe exactly how it works. And you know, we use a fraction usually that is the rise over the run, right? That's how we can formulate that number, that slope, so that we know exactly how to draw our line at the right angle. Today what we're going to do, and for some reason I feel like we already know this, you guys, so maybe I've just taught it too many times, but bear with me if it's new to you, but I think we've seen this before. If we've got two pairs of points that we know are on a certain line, and it can be different for any line, but let's just say we have two pairs of points that we know fall on a given line, and we're trying to calculate the slope of that line. We name one of the pairs of points x1 and y1. We name the other pair of points x2 and y2. Which one you choose to name 1 and which one you choose to name 2 doesn't really matter. As long as you keep your x's and y's straight and your numbers in their partnerships properly, it doesn't matter which pair you number accordingly. But we're going to use a very special formula to calculate the slope of a line. That's it. Copy that down, memorize it, put it on your pillowcase, dream about it at night. It's a very useful formula, and it always shows up in college level algebra. It always shows up on SATs and accuplacers and good stuff like that. So commit that one to memory. And basically what it tells you is that what it's good for is that if you have two pairs of points that you know fall on a given line, you can mathematically calculate the slope of that line. And that's exactly what we're going to do in our example today, which is example 87.1. I'm going to slide my paper up just a little so the light shines better on it. And it says, I'm not going to write all this down, but if you look at 87.1 on page 361, you'll see that it says, use the slope formula, that's this, to find the slope of the line that passes through, and then it gives us 2 points, and I'm going to copy them down. 2 and minus 5, that's one of the points, and then the other pair of points is minus 3 and 7. So this fits our criteria exactly. We have two pairs of points, we'll label them accordingly, and then we'll plug them into this formula. It doesn't matter if we call this point 1, or this pair the 1s or the 2s, it will come out the same either way. I'm going to call, whoops, my pen's skipping out on me here. I'm going to call the first pair that John gave us the 1s, and I'm going to call the second pair the 2s. Again, it doesn't matter, just keep it straight. Then it's simply a matter of plugging into our formula. So I'll go ahead and write that down, and you guys do it too. Just use our points and plug them into the formula. I do want to encourage you to do one thing. Use buckets. I'm begging you. John even talks about this in his lesson. Second, I'm trying to get my pen to write properly. It's really easy to make mistakes with the signs in these because we have negative signs in the formula. So please be sure to use buckets. Then when you fill, and then the other thing, I always mess these up because you start with the y2, which is 7. Why is my pen being so weird? I don't even know. Then you go to the y1, which is -5. Okay, easy to get twisted around in which numbers you're pulling from where. Then we go to x2, which is -3. And then we go to x1, which is 2. Okay? Then we just simplify. I hope you can see that. It looks really bad. 7 minus -5 is 7 plus 5. So the top we have 12. And then down here we have -3 minus 2. So that's -5. So what I'm going to do is I'm going to put my 5 on the bottom, and then I'm going to put a big minus sign in front of the whole fraction. So that is the slope of the line that passes through those 2 points. Super easy, super straightforward. You don't, excuse me, you don't even get a practice or another example problem to practice on because it's so straightforward. So, John makes one last point in this lesson, and that is that because it's so easy to mess up your signs in this calculation, but it's so easy to see when you look at a line whether it's going up or down, you should always double check this calculation against a picture of the graph if that's at all possible. Remember that a positive slope goes upward and a negative slope goes downward. So you always want to check your calculations against your picture and make sure that your lines are running in the right way and that you didn't mess up your sign. All right, that's it. That's all I have to say about lesson 87. Go ahead. There's only one practice problem, so you might want to work that together if you're with someone right now because there isn't an example for you to work. So carry on. I will see you for lesson 88.